Slope formula. Okay, so you're doing the slope. Average rate of change means slope. Okay, so think about like average speed, average velocity. Remember when it was like 120 miles in 2 hours? Okay, so average rate of change, just put in your brain however you can, is always slope. Okay, think of it rate of change, like rate, that word, right? It's going to be a slope. So distance over time is usually the vibe for it, but this is some rando function that they decided to use. So e to the pi, it's like what? So you just are like, okay, that stays. Cosine of pi is -1. They're going to be sass. They love cosine of pi. So I've seen that a lot. And then minus, and then e to the 0 is 1. Right? Not 0. I've seen that before. And cosine of 0 is 1. So that's where the -1 comes from, because you're literally getting 1 times 1. And then that's your answer. Now, this question is worth either 1 or 2 points. And again, we're going to be like psycho once we get studying for the AP test. This is worth 1. If it's worth 2 points, they give you this. Okay, so say you were being dumb and wrote cosine of pi as like 1 instead of -1, you could sneak a point. We're all about sneaking. You never leave anything blank. You can always try to sneak points. That's the goal. So you need to have that part, that front part, because you have to tell the grader what you're doing because they think you're dumb. So no offense to you, it's them. It's them. So, okay. So that's average rate of change. So like, remember yesterday we were doing like the slopes and stuff, and you're like, why don't we just do the one that's earlier? Like, what are we doing? Right, exactly, right? We got to this idea of to find the slope of a tangent line. Like, how the heck am I supposed to do that if I don't have 2 points? I only have the 1 point on the curve. You know what I mean? So the way you do the tangent line is that you deal with it as a limit, where this other point you're doing slope with is just psycho close to it, like right next to it, basically, or becomes it, which is like kind of wild, So today there's actually 2 definitions for the slope of a tangent line. This is the same one as yesterday, okay? So average rate of change, okay, that's like point A, point B, the slope between them. Like you travel 120 miles in 2 hours, 60 miles per hour, okay? That's like your normal slope, okay? So this one's like, I don't know how you want to say it, normal slope. Is that going to make sense to you? Maybe. But this is like quote unquote normal slope, okay? So that's average rate of change. You have point A, point B, okay? When we start getting like sassy, like tangent line, aka instantaneous rate of change, okay, that's when we're dealing with, oops, that's not a highlighter. Okay, that's when we're dealing with the limit. So it's literally the same equation, but now we're just talking about that point that I'm doing the slope with is just psycho close to where the tangent point of tangency is. Does that sound fancy? That's what it is. Okay. If you want to find the slope of a tangent line, okay. Oh, actually, I should write that word because I don't have point of tangency. They usually don't say that, but I'm just going to be safe to show you here. This thing, like that, this is the point of tangency. Point of tangency. It's like where the point is that the tangent line goes through. You can probably figure that out. This guy is the slope of the tangent line. Like, so you've been doing this formula since algebra 1. That's point slope form. It just looks all fancy with the F, the F of A business. But this is legit just y minus y1 equals m times x minus x1. It's just point slope. If you're going to take Calc 2, usually they have the y1 on this side. Can they agree for once? No. The answer is no. They can't agree. It's just like, whatever. Point slope form, or if you plus over the y1. Don't even distribute. Don't waste your life unless they ask you. Do you guys know where that formula comes from, by the way? It's kind of fun. You guys know slope formula, right? Y2 minus Y1. I'm just not going to do the Y2s. Okay? It's still the same thing. Those subscripts are kind of, they're just there to organize your life. Okay? Now cross multiply. See it? Cross multiply. See it? Point slope form. Do you see that? Look at that. Cute little proof. Have you seen that before? That's where it comes from. So, anyway, as far as like say we have to do a table, what is going on with this? It's not working. Do I have to be on the pen? Yep, there it is. You don't need to know that. I just thought that was fun. All right, so Facebook rate growth. Sorry, that was a little old school, but we're just going to go with it. The following table gives the number of daily users of Facebook averaged over each month shown. Estimate the instantaneous rate of growth of Facebook users for June of 2011. What are the units of your answer? Okay, so for the way you do this is you have to find the instantaneous rate of growth. Okay, so what that means is I'm going to have to do a slope thing. Okay, so whenever they're doing like instantaneous rate of change or rate of growth, or like you see the word instantaneous, that's like tangent line, slope. That's got to be your brain. Okay. Now because these are equal, there could be another way to do this, but this is the way that works every time, because here's my point, right? I wanted a June 2011. So I have like numbers there, but like to figure out the instantaneous rate of growth, I'm basically going to just do a cute little slope with those, with the one on the left, and then a cute little slope with the ones on the right. Okay. You technically could do this another way, but this way always works. So like, for example, if these were not equally spaced, this way always works. So what you're going to do is you're going to find the slope with the lower one, the point. Then you're going to find the slope with the upper one, and then you'll average them. Okay. So it's like you're doing, so basically with this red one, I'm going to do 417 minus 372. So I'm just doing slope formula, and then 6 minus 3. So y2 minus y1, x2, or x1, and I already did this in my head, 15. And then, wait, what's the unit again? So I did, what's the 4, 1, 12? Oh, why did I write 14? Jeez Louise. Jeez Louise. Okay, so what is that? Millions per, and then what was the time? Month? And you guys, do you see where I'm just getting the unit? It's super easy when it's a table. You literally just write, oh, what's the Y? Millions, you know? So you put millions on top. And then you're like, what's the time? Month, you know? So with the table, you can always cheat with the unit. So you get that, and now you're going to do the blue one. So you're going to go 457 minus 417 over 9 minus 3. And then you math it. 9 minus 6. Yep. Thank you. Saving the day. And I got a gross number. Oh, wait. What am I doing? That's the answer. 13.3333 millions per month. So then to find like the instantaneous rate of change is that you would average those. So you find one on the left, one on the right, and then you average it. Okay. Say they wanted a month like between June and September. Do you know what I mean? Like say it was like, I don't know, like August or something. I don't know. I'm just making up something. Like if they were doing a month in between, you would just find the slope between these two, you know? So if it's like an actual data point, find the slope on the left, find the slope on the right, and average it. But if it ends up being like legitimately in between one of these, just find the slope with one. The ones on like the two between it. Okay. Oh, I didn't even average it. So averaging it, you just divide by 2. So you can go 15 plus 13.3333 and divide by 2. So then that's the 14.167 millions per month. Okay. So that's how you do it with a table. If you need to, that's like a weird one. They'll say like that's an average rate of change problem, but it's like they kind of say it weird, you know? So you're estimating using average rate of change. Okay. Does that make sense? Is everyone okay with that? Okay. All right, so here's that first definition again. So this guy, the idea with this one is here's our point of tangency, okay? And that whole idea is that we're taking that point. So the variable is your x. The A business is like where you want your tangent line to be. Okay, and it's always like that. Like it's always minus the point of tangency. Okay, so like if you were gonna do like an average rate of change, so like an average, oh come on, I'll open this again. Come on. So if you're gonna do an average rate of change, like say it's with Q, thank you, jeez Louise. Okay, that's just like normal slope. So if you were doing average rate of change, you would be doing like f of x minus f of a over x minus a. That would be an average rate of change. Okay, now if I was going to do a tangent line, like I said, the tangent line involves the limit because that f of x guy is getting psycho close. Okay, so that's again what we did yesterday, but the reason it has the limit on it is because that variable, so like the x, the other point, wants to get super close to A. So A is like where your tangent line is. And the formula is the same old. You're doing f of x minus f of a all over x minus a. Okay, but this is like where you want your tangent line. Okay, so that's your first definition. So then what you're going to do now is you're going to actually figure out the slope of a tangent line using the formula. Okay, so you have this curve, nice projectile. You know, in real life, if you throw things, you know, gravity, right? Kind of like brings it back down. All those projectile ones, like physics people, that's how we do all of those. Okay, so the slope of the line tangent to the graph. So slope line tangent, that's a calculus problem. So the second they say slope of a line tangent for part A, that means I am doing a limit. Okay, as x is approaching something. So that's the juice. We want to do a limit. Okay. Now, where is I want this tangent line to be is right there, right at this point. So I want my x to get really close to 1. Okay. So it's whatever your x is that you're getting really close to. And the formula looks like slope formula because it literally says slope. So what I'm going to do is I'm going to figure out f of x because that's my variable point that's getting closer. But then my OG point is where it happens at 1. So this is, again, this ordered pair, which we'll fill in a second. But that's how you would set it up. So your x1 and y1 are always where you want your tangent line to be. So now this is where we go in for the algebra. Okay. So you're going to bring your limit every time. Okay. Approaches 1. And I'm going to write f of x. Okay. So I'm going to replace f of x with, f of x. You see that? So I'm going to put negative 16x squared plus 96x. Okay. So that's like the f of x part minus f of 1. So f of 1 is like the y, right, at the tangent line. So this is your f of 1. This is like f of 1 here. Why is this crapping out on me so much today? Sorry. Come on, come on, come on. This is your, there you go. Okay, so that's going to be where my 80 goes. Okay, and then this bottom part, you really can't really do anything because you have, oops, I did that in red, be x minus 1. Okay. All right, first thing you do, okay, again, this is your tangent. Plug in 1. Maybe it'll work. I'll tell you right now, it doesn't work. Great. It's indeterminate form. So if you plug 1 in, so now we just do our normal limit stuff, is if I plug in 1, I'll get 0 over 0, which is annoying. So now we're going to have to do some algebra. So we're going to go limit as x approaches 1, and I'm going to mess around with that numerator, which is a little terrifying, I'm not going to lie. It's a quadratic, so do I have to factor it? Oh, okay, it's a quadratic. If I have to factor this beast, I don't like the negative. I'm sorry, but I can't. I don't like the negative on the x squared. It hurts my brain too much. So what I'm going to do is you can actually factor out a negative 16. Thank God. Right? Because now you have a positive x squared. And now, because I took out the negative, right, that's going to turn into minus 6x. And then that, I took a negative out of the negative 80, so that ends up being positive. Does that make sense with everybody with 5? And now it's like more normal looking to factor. And I don't know about you, but with all of these, you'll see that you can kind of cheat a little, because on these problems, you should always be able to divide out an x minus 1, or like whatever your denominator is when you're doing these things. So I kind of am like, well, I bet there's an x minus 1 in it. If I'm having a bad factoring day, I can always be like, well, I'm sure that's in it. And sure enough, it is. That's going to be x plus or minus 6 here, or minus 5. Right. And then you can be like satisfying, woo. And then now you're evaluating x approaches 1 of negative 16 times x minus 5. And now you can plug it in. So you're going to plug in a 1 into your x once you have it factored. So that was 64. So that's the slope of the tangent line, 64. When they ask you for the slope of a tangent line or a straight up slope, the answer is always going to be like a number, because it's like a slope number, right? Yeah. No, because like once you plug the 1 in, you like evaluated it. So then once you plug the 1 in, it's just done. Like you can drop it. That's a good question. Good. Okay. Oh, and then there's B. What is going on? Find the equation. Oh, that's easy. Throw it in point slope form. You literally do y minus y1. I don't like that f of a thing. That's just me being whatever. I like this one because it like brings me back to my algebra roots. You know what I'm saying? So like, oh, what's my x1, y1? Remember, it's all about this guy, the 1 and the 80. So you already have the point. So you're just going to throw y minus 80, and then your slope was 64, and then x minus 1. So like this is the point you were dealing with the whole time, so that shouldn't be an issue. And then the tangent is just like after you kind of suffer for a while, you plug that in. Okay. So when they find equation of a line, that's it. This is it. Don't even solve it. Waste of life. I wouldn't. Okay. Is there any questions on where any numbers come from with that? Okay, because I'm going to show you the other formula. Do you remember that h thing? Oh my gosh, it's coming full circle. Do you remember the thing with the h? The limit with the h? I was making you do stuff with it. Well, this is why. because this is what we're going to be doing here. This is a different formula. This one is actually better, believe it or not, because in the next unit, we're going to find equations for tangent lines, which is kind of wild. But essentially, the way they think about this, instead of it being like a separate point, you know how this was like f of x before? It was like x minus a. They think of it as like this point plus a little away from it. So they think of it as h being like the x, like a distance away from the point. So I'll go through that a little bit more. Plus that formula doesn't even look like slope right now. So basically the numerator should be normal. So this one is like, this is like your y2. And then this is like your y1. And then they just didn't write the denominator because if you wrote it, it'd be like, this would be your x sub 2, you know, minus x sub 1. Right? Like if you followed the formula there. And do you see what happens with the A's? You know, so it's like, why write that? Because it's like they just go away anyway. So this is still average rate of change. This is the same formula. It just looks like a little weird with how they talk about the Y2. Instantaneous is the same thing now, but instead what they're doing is they're talking about the distance getting close to 0. Like they want that second point to be like really, really close to A, approaching 0. So think of H as being like a distance. Okay. So it's distance from the tangent line. Okay. Here, maybe I'll write that. H is distance from tangent line. Okay. So when you think about it with this definition, you would say like, okay, the slope of the tangent, right, is going to be the limit. And what's happening is like, okay, here's your tangent. The way they think of it is very similar. They're going to think of it as this being a comma of f of a. So nothing's changed with that. So a, f of a, like that's still like quote unquote the normal point that we're dealing with. But instead of it being like f of x, like some other point, they think of it as or they think of, sorry, oh my gosh, it's technology, man. They think of it as a, like the same as that one, but just a tad more. So h is like the extra they add to it, like a little further down. And then f of a plus a. That's how they think about that point getting closer. So this distance here is like your h, like the distance between these two right here. This is your h. So then the way you set that up is you would do the other point, f of a plus h minus f of a. And then, like I said, you could write it just like our normal slope formula. But what I'm saying is like the a's cancel. So why waste your time? I would just leave it with just the h underneath it. Okay, because it just cancels. So it's just easier not to write it. Okay. So again, this is still the same, the point of tangency, just the denominator doesn't look like it because it's like gone. So, all right, so then we'll do one more, or maybe we'll just do, I want you to start on the homework. Maybe we'll do the second definition for this and then we'll call it because I want you to, and I want to give you your quizzes back. So we already did definition 1. Just as a reminder, that's this one, the limit as x approaches. So this one would be 3, and this is the like the quote unquote normal slope formula because it looks more slopey looking. Do you know what I mean? Because it's got y2 minus y1 x over x2 minus x1. So you would like plug it in and do what we did on that other example. Definition 2 is with that h thing, okay? So the idea with the definition 2 is you would take limit as h approaches 0. Every single time it's h approaching 0, so that you can it's kind of nicer in that regard. And the formula for this one is you're going to go f of, and then RA, so like our tangent, where is it? 3. This is where I want my tangent line to be. So slope of a tangent line, that's where I want my tangent line to be. So I'm going to put 3 in, and then it would be plus h minus f of 3. And then remember the A's or the 3's would cancel on the bottom. Maybe I'll just do that to be safe, because you would have this technically, right? But the 3's would cancel. Okay. So I usually just go straight to H. So then this is going to be fun. Is you're going to plug in that 3 plus H in for F. I don't want to keep scrolling up, so I'm going to read, what was it again? 3x squared minus x. Okay, so I'm going to plug in 3 times 3 plus h squared minus 3 plus h. So that's like, I'll do this. That's like the f of 3 plus h right now. Is everyone good with that? Now we need f of 3. I usually do this off to the side because I don't want it to get, it's already looking crazy. So now f of 3, that means I just plug 3 in quick. Excuse me, so what is that? 9, 3, 27, 24. I'm not having a day. Do you ever have days where you can't add very well? Sometimes I have those days. So this, I just got the y because they didn't tell me, which was annoying. That other question, remember that other question with the 80? They told me what the y was, which was like way better, but whatever. I just, if I needed to get that number, I'd just plug 1 in to get the y. They gave it to me, so that was nice. Okay, and then what do I have on the bottom? Just straight up H. Okay, now alge. Actually, let's try to plug 0 in and see if it works. Just kidding, it won't. So we're going to algebra it up. Okay, so don't do anything dumb when you're like distributing. Remember, oops, that'd be a 6. Minus h minus 24 all over h. So I just squared out the 3 plus h. So remember, don't do anything illegal, right? That's like 3 plus h times 3 plus h. Then we're getting after it. Limit h approaches 0. 27 plus h plus 3h squared. Oh, I could put the negative 3 and negative 24. What is that? Limit as h approaches 0. Okay. What? Hey, the 27s are out. Yes. Do you guys talk to yourself like this? No? Maybe? 17h, 3h squared all over h. Right? Am I getting this right? I'm not being dumb, right? I think so. Okay, yeah, I'm still good. All right, and the h's, divide an h. Okay, cool. And limit h approaches 0. So what do I get? 17 plus 3h. Whew. Okay, then grand finale, plug 0 in. So what do we get? 17. Hallelujah. So we got slope of the tangent line is 17. Okay. What is the equation? So people like way overthink this problem. It's literally algebra, throw it in point slope. You like already did like the heavy lifting. You've already done like this is literally this, all it is. And then you plug in the point and the slope you got. What makes this calculus is that guy, little m. The m is what makes it a calculus problem. But you've already kind of done that stuff already, so. Wait, what was the point? What was the order pair again? It was 3, right? 3 and 24, right? Yeah, so 3, wait, 24. Put the 24 in the y spot, guys. Okay? And then the 3 in the x spot, and then the slope was like the most painful part. That's always that number, so you just throw that guy over there. And then that's it. So I wouldn't solve it, just leave it. Just leave it. If it's on multiple choice and they have it as y equals, obviously would solve it. But if it's on F or Q, nope. I'm going to avoid any dumb algebra mistakes as I can. So that's the plan. All right, I'm going to give you these quizzes back.